In this video, we begin our discussion over section 2.2, separable differential equations. This is a step up from the simplest method that you guys have seen, where the derivative is solved for with only the independent variable on the other side. This would be a different case. This is now what we were doing beforehand was looking at it like this. We were like, okay, our derivative is equal to some function of x, of just the independent variable. But now we're going to look at, what if I have two functions, but it's a function of x times a function of y that equals that? Meaning, like, I can separate them by division. So the method here, what works, okay, so if I have this equation, if I take both sides and divide by g of y and multiply by d of x on both sides, take a minute and pause if you need to, we should get that equation, multiplying both sides by dx and dividing by g of y. All right, from there, notice we have a dy and a dx, like separated like that. This method tells us that, hey, I can then integrate both sides because I have only y's on the left side and only x's on the right side. So I take the integral of both sides, and then I try to solve for y if I can. It's not going to always work. Actually, this first example we're going to do, it's not going to work out. To solve for y, explicit means, let's write these out for a moment. Explicit is y equals. Implicit is not that. So not that, right? Not y equals. It could have 3y, 5y, plus x times whatever. It could be some crazy equation not solved for y. This is the method. It's pretty straightforward. Once you see a few, you're going to be like, oh, great, that's fine. Some of you guys may have actually even seen this method in Calc 2. I know from my Calc 2 class, we did get to a few of the diffy Q parts. That's changed since I've been in school. But here we go. Let's do one example. All right, so example 1 here, solve the separable differential equation. Now, one thing that is coming up, and I do want to make sure you know this, is on a test, I'm not going to say solve the separable differential equation. I'm just going to say solve the differential equation. So we need to start working on what makes this separable. All right, I got a dy dx on the left side, and then notice that I have a y times that. I can move all the y's to the left and keep all the x's on the right. That tells me that it is separable. So I'm going to divide both sides by y. I'm also going to multiply both sides by dx. So notice, that's what I get. Multiplying both sides by dx and dividing both sides by y. All right. We are going to take the integral of both sides now. All right, I write out my integrals there. All right, and now I go ahead and I take my integral. All right, and then I get, okay, so that one, the integral of 1 over y, this thing comes up a whole lot. So make sure you do know that. The integral of 1 over anything is ln of anything. Sine, I like to write down, I know it's a cosine of 5x, and then I work from here, okay? The derivative of cosine is negative sine, so I need to make sure that's a negative, that way it makes a positive. I also need that to be a 1 over 5, because I'm going to get the chain rule from that 5, plus c. So this is a u sub, if you want to try, if you need help seeing that, let u equal that, so du is equal to 5 dx, do all the proper subbing, do your integral, and that's what you'll get. This is our solution. I know it feels very strange, but we could stop there, and we get an implicit solution, right? I could solve for y, and we'll deal with how to deal with that ln in a little bit. But as of right now, we're going to leave it implicit because it's not going to be pretty if I try to solve for y. It's possible that there is no such function where y satisfies the equation. This wouldn't be an implicit solution if that was the case, but it does work in this case. And we're going to, there are some theorems and stuff talking about existence of solutions. We're not going to focus on that on this semester. I'm going to leave that for you guys going off to PDEs and stuff like that for your classes. If you are curious, I do have videos for it. I can show you or send you other people's videos and stuff like that. I'm just not totally concerned about it for this course. All right, so you will be able to solve for y sometimes, and sometimes you won't. How you would be able to determine is for a test, I'll probably be specific. I'll say solve the differential equation for an implicit solution, or explicit, and I'll just clear up that anxiety of do you keep going or not. If you get an implicit solution and the implicit's correct, and you start working towards the explicit and you mess it up because it's not possible, you're going to get credit for the majority of it. I do have to count a little bit off, but you'll be fine. I'm great with partial.